Okay, so let's get started. We're going to be taking a look at working with open loop style boost control found within our Motec M1 programming. Now, this is going to be assuming we're working with a 3 or a 4-port boost solenoid, and we want to be able to control an internal or an external wastegate to increase our boost pressure past whatever that actuator or wastegate spring level is going to be at. So if we have a 10-pound wastegate spring or wastegate actuator, and we want to go to something like 15 or 20 psi of boost pressure, we're going to be utilizing a boost solenoid to increase our boost pressure, and we're doing this in an open loop manner, meaning the Motec is not going to have feedback to the duty cycle we send to the boost control solenoid to drive us to the target. We're going to have to actually set everything up so it's going to work properly. We're going to be digging into how the boost control works in this training module, understanding all of the tables and compensations that can come into play. This is the most simplistic way to control boost with your Motec. We'll find in the next tutorial, we're going to introduce the closed loop aspect. It'll build on what we've talked about in this training module. So what you have learned in this training module can be applied to the next training module. So let's jump in here and take a look at where we can find our boost control programming. We're going to move from our fuel tuning window and go over here into our boost setup. This is going to be where we actually turn on the boost control feature and allow it to start to work. We're going to find we have another window labeled Boost PID. This is to take a look at how the boost control is performing in both open and closed loop type of situations. Now we're going to be reviewing open loop, so a lot of what you see in our time plot here or the channels in your channels list as you're reviewing your data won't apply in an open loop situation, but we still can get an idea how the system's going to work and how everything's going to all fit together in this training module. Let's jump in here and take a look at our boost setup. And we need to go up here into our very first portion in our setup window and go in here to boost and assign an output for control to control the boost control solenoid. Now, before we do that, I want to briefly talk about the configurations we're going to find ourselves in with our boost control solenoid in an internal or an external wastegate. The way we actually route the lines coming in and out of the boost control solenoid will be different. Now, I'm only going to be covering a 3-port boost solenoid because that's what I generally like to use. I find the 4-port boost control solenoids are going to be very, very coarse in boost adjustment, and it makes closed loop boost control very, very difficult. In an open loop format, as we're talking about here in this training module, it also is going to produce inconsistent boost results. So I would always recommend to run a 3-port boost solenoid whenever possible, and that's what I'm going to be covering here just real quick, making sure we have our orientation correct on our actual solenoid vacuum routing. So the first example here is going to be an internal wastegate with a 3-port solenoid. We're going to find we have our ports 1, 2, and 3 on the boost solenoid. Port 1 will act as a vent. Port 3 will go from your compressor pressure source. So compressor cover we can see in this example, it's pretty typical. It could also be a charge pipe, and it's going to go route into port 3. Then port 2 is going to be used to control the actuator. It's going to go to the nipple on the actual internal wastegate actuator. What we'll find is when we're not energizing and sending any actual output from the Motec to the boost control solenoid in this orientation, that we have our pressure flowing in port 3 and then right out port 2. In this orientation, this is known as a normally open configuration. Once we start to energize the solenoid and command anywhere between 0 to 100% duty cycle, we're going to be having a bleeding effect and bleeding air pressure out of port 1 and putting less air pressure going to port 2. If we start to cut off our actual pressure supply to the internal wastegate actuator, that nipple, we'll find that it's going to start to keep that wastegate flap shut and generate more exhaust mass flow and drive our turbine and compressor speeds faster, ultimately generating more boost. So we'll find that port 1 is going to be our vent, port 2 is going to be our feed to the wastegate actuator, port 3 is going to be our pressure in. Very, very simple orientation. So we have to make sure you're wiring everything, or you're routing everything, I should say, in your configuration here exactly as shown, or else you won't have the boost doing exactly what I'm talking about here in this training module. You're going to have it inverted or even overboosting. Okay, so the next orientation we have here is going to be for an external wastegate. So we can see in this particular configuration, we're going to have our turbocharger, we have our wastegate, we have our boost control solenoid. Now on an external wastegate, we're going to have both a top and bottom port reference on the wastegate itself. In this particular orientation, we're going to have our compressor cover feeding our pressure source to supply to port 1 on the boost solenoid, as well as the lower port on the wastegate. So they're sharing that boost pressure reference. Now on the boost solenoid, port 2 will then go to the top port of the wastegate, and then port 3 will be open or vented to atmosphere. In this particular orientation, the solenoid, when it's not energized from the Motec, will be in a normally closed state, meaning no pressure will pass from port 1 to port 2 to the top port on the wastegate. We'll find all of it vents out port 3. Now, as we start to energize the boost control solenoid between 0 to 100% duty cycle in the output control, it will start to apply more and more pressure to the top port on the wastegate. That will act as a multiplying effect to the rated spring pressure. So if the rated spring in the wastegate is 10 psi, we should see our base boost pressure before the solenoid's energized and we introduce any boost control as 10 psi. As we start to ramp up the duty cycle output to the boost control solenoid, that'll allow more pressure going into the top hat assembly, and again, acting as a multiplier and increasing our rated spring pressure. We can typically find with an external wastegate that we can go at least 3 to sometimes 5 times the spring pressure. So if the spring pressure is something like 5 psi, you could typically see at least 15 to 20 psi out of a 5 psi spring, sometimes even more. It really depends on your exhaust back pressure in your exhaust manifold before your turbine on the actual turbocharger. So it's going to really depend on your exhaust manifold pressure. But that's typically a general rule of thumb. 3 to 4 times the rated spring pressure is what we can get away with. So if you're trying to size your wastegate spring in your external wastegate, and you know that ultimately you want to hit something like 30 psi boost, well then you're probably going to need somewhere between 6 to maybe 10 psi base spring in there, and then you can turn up the rest with your boost control solenoid. We don't want to run really high wastegate spring pressures because it's going to make the boost control very difficult. Also, the adjustment from the boost control solenoid, very coarse an adjustment. So a small output in control from the Motec in the duty cycle control to the solenoid can produce a very large boost swing, and that's not going to be optimal for boost control. So we generally want to have a lower spring pressure, and then we'll use the virtual control, sending the 0 to 100% output to the boost control solenoid to turn up the boost. We cannot turn down the boost from the wastegate spring. That's another thing a lot of people get confused on. If your internal wastegate actuator is rated at 10 pounds or 5 pounds, or your external wastegate has a 20-pound spring, we can't go lower than that rated actuator or spring pressure. So it's another thing to consider. You don't want to have too much spring pressure, too much actuator pressure, because that definitely can be detrimental for traction reasons if you're in a traction limited car. So all things to consider as we're going through and setting up the actuator for an internal wastegate assembly or the spring pressure in an external wastegate. So now that we understand that...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.